Hello students and welcome to Unit 5 Part 2 Lesson 5. In this lesson we are going to learn to write equations for a variety of relationship representations. We will specifically be looking at how we can take a real-world situation, a set of points, or a table and represent the relationship as an equation. We have studied equations already, however, we have only looked at equations that contain one variable, where that variable represents one unknown quantity. Today we're going to look at equations that have multiple variables. To get us started, I have a few uh, real-world equations that apply to life. So we have a plus s plus k plus g equals s. Remember, each variable represents an unknown amount. This equation represents the saying, attitude plus skills plus knowledge plus goals equals success. L equals 0.10h plus 0.90r, which stands for life is 10% what happens to you and 90% how you react to it. Just some fun equations for life to get you thinking about how a variable represents an unknown amount. Now let's review some vocabulary related to the word equation. An equation is a statement that two amounts are equal. It defines one variable, which is the dependent variable, in terms of the other, the independent variable. A basic example to the layout of an equation is that it has two variables, an equal sign, constants, and operations. They can contain all of these constants, operations, and variables, but they must at least have an equal sign connecting whatever other types they have within them. Now, today we are going to look at writing equations for a real-world situation and a set of points and an input-output table. But how we do both of these will be the same because we know that when you have a set of points, you can organize them within an input-output table. Or if you have an input-output table, you can rewrite it as a set of points. So essentially, both of these are the same representation, just reorganized differently. Now, if we have a real-world situation, this is what we're going to do. We will read the real-world situation the whole way through. Then we will reread the situation and mark the text for key operational words, constants, and unknown values, which we know are called variables. We will third use our markings to write an equation because that's going to let us look only at the key phrases. Now, if we're looking at a set of points or an input-output table, our first option is if we see that there's a constant rate of change, and we'll talk about what that means in a little bit. We will write a ratio to describe the constant rate of change of the dependent variable when the independent variable changes. We will then use that constant as the coefficient of the independent variable. So say we get the number 2 here for step 1, then we'll write the 2 in front of the x since that's our independent variable. So we'll have like y equals 2x. And then third, we'll add or subtract to adjust the equation to fit all of the points in the set or the input-output table. Now, we have to have a second option because sometimes equations do not have a constant rate of change. If there is not a constant rate of change, list some possible relationships for the set of values. Be thinking about exponents, absolute values, and square roots because those do not have a constant rate of change. Also, determine if the relationship works for all the values. It has to work for every ordered pair in the set or in the input-output table. And then last, write the equation. Now, I don't expect you to be able to do this so far, but I want you to reference this list as we're doing some practice problems. Now, as we read real world situations and we were trying to mark the text for those keywords, we must know the keywords that indicate add, subtract, multiply, divide, or an equal sign. So what we are going to do is we are going to write a plus sign, a minus sign, a multiplication sign, a division sign, or an equal symbol to represent each keyword that we're going to look at. Now note, when we write right now, we're going to use this division sign like this, but however, when we write an equation, we're going to use a fraction bar rather than a divide symbol, okay? All right, here's the words we're going to look at, and we're going to think about whether they mean add, subtract, multiply, divide, or equal. The sum of add will be equals the product of multiplication less than subtract. Per in a statement. That means in a statement that ends with a period. Per in a statement means multiply. Per in a question, however, means to divide. The difference here is the apples cost $2 per pound. That's a statement, that's multiplication. How much did each cost per pound? That means that we're splitting it, and it'll always be in a question. All right, gives. If we give something to somebody, we either add or subtract depending on whose perspective you're looking at. Of means to multiply. Was means equals. Are, there are means equal. Each in a statement, which means ending with a period, means to multiply. Each in a question, however, means to divide. Sells for, that means it equaled. If it sold for, that means it equaled. Were, that's equals. In addition to, add. Gives, again we could have add or subtract for that one. Decreased by, subtract. Is, equals. Combined, if we combine two peoples, we add them together. Times, multiply. Yields, yields means to result in or equals. Minus, subtract. Twice, this is a very specific one, it means 2 times. Perimeter, add up all the sides. Remains, subtract. How many remains would be subtract? All together, add. Fewer, subtract. Both, meaning 2 times. Twice and both have 2 times. Total equals the ratio of, divide. Constantly increased by, that's multiplication. Out of, division. In all, add. The quotient of, divide. Costs equals. Earns, add. Split evenly, divide. Multiplied by, times. The difference, subtract. Area, multiplication. However, you need special formulas for area. See your formula sheets. Increased by, add. And percent is a symbol of division. Now let's use those to mark the text, and I do want you marking the text with me because this is an expectation that I have for you to see the way you're thinking about these keywords. Now step 1, if you look back at your list, is to read the entire problem, and then we'll reread it and mark it. Every weekend, Tasha babysits her neighbor's kids for a few hours. For each hour, her neighbor pays her $5. Write an equation to represent the total amount of money Tasha earns babysitting. Well, when we hear for each, that means we're going to multiply by the number of hours. What are we going to multiply the number of hours by? $5. So we have 5 times the number of hours. And that is how she gets the total amount of money, which is dependent, which would be our Y, on the number of hours. Do you see how I read it the whole way through, and then I went back through rereading parts of it to find those keywords. Now, define our independent and dependent variables. Our independent variable is the number of hours worked, which we know is the X value. The dependent variable is the amount of money earned, which we know is the Y value. Now, we actually have our entire equation here. Y is equal to 5 times X, or 5X. So this equation can be used to figure out any number of hours that Tasha might babysit. Let's look at another example. Reality Rentals allows customers to rent construction equipment for an hourly charge. To rent a jackhammer, it costs $35 plus an additional $10 per hour. Write an equation to represent the cost of renting a jackhammer. So as we read this, we see that this first sentence is actually extra information, describing for us how Reality Rentals works and giving us background information. This second sentence is where we see all the keywords we need. It says it costs, or the cost equals $35, that's a constant, plus, that's the operation, and additional, which just clarifies that we're going to be adding, $10, there's our constant, per keyword for multiply, hours. And we can see that we have two variables, two unknown amounts. The cost depends on the number of hours. So as we fill in our independent variable with number of hours, we know that that is going to represent our X value. And that will determine the total cost of the rental. Which we know is the Y value. Now look at our equation. We have it written all out. Y is equal to 35 plus $10 times X, or just touching X. And there's our equation. Let's look at one more example, and in this example we're going to mark the text as we go because we are almost at 15 minutes. For your birthday, your grandmother buys you a cell phone. The monthly cost of your cell phone depends. We're going to call that Y because it's depending. That's our dependent variable. The monthly cost of your phone depends on the number of minutes, which we're going to call X, that you use, and the number of text messages you send. So you can see that there are two independent variables affecting the monthly cost. Now it goes on to say it costs, or the monthly cost is 10 cents per minute, which we call it X, and or plus 5 cents per text. Write an equation to represent the total cost of the cell phone bill. So as we talked about, we know we have two independent variables, the number of minutes that we use, which we called X, the number of text, which we called W, and Our dependent variable is the cost, which we called y. We also have our equation here based on our keywords, and we have that our equation is y equals 0.10x plus 0.05w.